Okay, so welcome to our YouTube channel. In this video we will see the bubble sort, how it is work and program and logic are all about the bubble sort. Okay, so first of all let's see the little theory about bubble sort. So it is the simplest sorting algorithm, and this sorting actually how it is work. And so each pair is compared, means all the adjacents will be compared, and there is a adjacent we can say like this. So it will compared, and on the basis of that, if they are not ordered, then we will swap it. Okay, it is also called comparison based algorithm. Okay, and not suitable for the large data sets. And complexity, how the complexity in average case and worst case, it is big of n square, and where n is the number of items. So let's see all these things how exactly. Okay, so first of all let's see we see the definition, that it is a simple sorting algorithm, comparison based algorithm it is also called, and each pair is adjacent is comparison, and if there is not in order, then we will swap it. Okay, and two more points which is not suitable for this, and complexity. Okay, so let's see the logic behind this, how it is work. Suppose we have elements. I will not write the element of what is the exact value. Suppose I have 5 elements. Okay, let's see the logic how it is work. So if suppose I have 5 elements, so what will happen in there is iterations. Okay, so if we have n elements, then iterations will be also n, and suppose here is 5 elements, so iterations will be 5. Okay, so how it is exactly work. So adjacent pair are, as we say, that each pair adjacent is compared. Okay, compared. So this is the pair of we will pick a pair, means adjacent pair, neighbors, and we will compare to them. If they are equal, or it is means if this first one is less than to next element, then we will not swap. Okay, in that case we will not swap. And suppose the first element in this element is greater than this element. Okay, this element is greater than this element, then we need to solve, because greater means a large element is coming before the short element, so we will swap in this case. Okay, so this is done till here, means first we will compare to them this two, and then we will swap on the condition of this, then again apply in these two elements, then this two and this two. So this will happen in first iteration. First, in the next iteration, what will happen? Same thing we will do. We will compare one by one, and on the basis of that, whatever will be required swapping, we will swap, and iteration 2 will complete it. In this way, at the iteration 5, the all elements you will see that they are sorted. Okay, they will sorted on the last iteration. At the last we will see that all the elements are sorted. So in this way it is work. So let's see the actual how it is work. So let's see with the elements. Okay, so suppose we have a list where 5 elements is this 50, 20, 10, 40 and 30. Now if I wanted to sort them by the bubble sort, how exactly it will work. Okay, so what is happen that in a first iteration first what will happen, first compare to this two. Okay, and we will compare that 50 is and 20. If there is a condition, if this element at the left hand side and right hand side, so if left hand side is greater than, then we will swap. Okay, swapping will done. And if conditions is, this is the first condition, and second conditions, if it is less than or equal, then we will not swap. Okay, so let's see, 50 and 20 is 50 is greater than 20. So what will happen, we will swap it. Swapping will be done. So 20 will come here and 50 will come here. Then we will compare to this two, means 20 is coming here, 50 is coming here, means 50 is here now, and 20 is here, so 20 50. Now 50 and 10 we will compare to them. So which one is greater than? So what is the condition exactly? Same condition is that left hand side element is greater than right hand side, so we will swap again. So 10 will come here, okay, 10 will come here, and 50 will come here. Now in the next what will happen, 50 and 40 will compare, and as we see that 50 is greater than 40, okay, in same case left hand side elements is greater than right hand side, so what will happen, we will swap them. So 40 will come here, and now 50 will come here. Now at this next time what will happen, 50 and 30, 50 and 30, okay, so here is suppose 30, this is the element, so 50 and 30 we will compare, or same conditions happen that left hand side element is greater than right hand side element, so 30 will come here, we will swap it, 30 will come here, and 50 will come to here. So at the first iteration, this is the first iteration, okay, so at the first iteration the large element come to the last, means at the position, at the exact position in the first iteration. Same in the second iteration we will see, that we will find this first element in first iteration. Now second element we will find the exact what should be the element here, okay. All swapping will done in such same way. So 20 and 10 will compare. What is the condition, left hand side element is greater than right hand side, so we will swap it, 10 will come here, 20 will come here. Okay, so 20 is greater than 10, so we just swap it. I hope it is clear to you. And now the next thing what will happen, 20 and 40 is compare, so 20 is now the second condition will apply, 20 is less than 40, right? So what will happen, swapping will not swapping means it is exactly come, so 20 will stay here same, and 40 will come here, okay. Now in the next what will happen, that 40 and 30 will compare. So what is the condition, the first condition that left hand side element is greater than 40 is greater than 30, so what will happen, swapping will happen, so 30 will come here, okay, and 40 is come to here. Now 40 is come to here. Now 40 and 50 will compare, and what is the condition, second condition now true, that left hand side element is less than right hand side element, so what will happen, we will not swap it. So in the second iteration we found the exact value, second last value, okay. Now in the iteration number third what will happen, we will get this number, okay, this three numbers. So as you know that here 50, here 40, and now what number should become, so let's see, it is start from here same, 20 and 20 will be compared. So what is the second condition is to that 10 is less than 20, so not swap, okay, so exactly 10 will come here. Now at the next condition 20 and 30 will compare, so 20 is less than 30, so again not swapping will not done, okay, 20 is come same, and same things that 20 and 30 will compare, so 20 so we have done, okay. Now 30 and 40 will compare, so same condition that left hand side element is less than right hand side, so 30 will remain the same here. And now at the next condition what will happen, 40 and 50 will compare, and 40 and 50 the second condition same, okay, so we will not swap, so 40 will come here, 50 will come here. In this third iteration we see that it is sorted, okay, but in the as we know that everything is done, so no swapping is done, so we can break also. If we can logically we can do the things that if no swapping is done means we know that there is sorting is done, okay. But if it will not break, then same, if suppose it is not done, then what will happen, the next exact position value we will get, from the last iteration 4. Okay, suppose that this will not sorting, then this will element we will get in this element iteration 4, and the last iteration 5, iteration number 5, we will get this, means all element will be sorted. If we have n number of elements, we required n number of iterations. Okay, so in the fourth iteration, what will happen? Same things, 10 and 20 will compare. So as we know that second condition, that 10 is less than 20, so 10 will remain here. Okay, now 20 and 30 will compare, and 20 is less than 30, so 20 will come here. Then 30 and 40 will compare, so 30 is less than 40, so 30 will come to here. Now 40 and 50 will compare, 40 is remain same, and the last 50 is come here. Okay, in the last iteration, what will happen? Same, 20 and 30, 10 and 20 is compared. 10 is less than 20, so 10 will come here, 20 will come here, 20 and 30 will compare. So same things, 20 is less than 30, so 20 is come here, 30 and 40 compare, so 30 is less than 40, so no swapping. 40 and 50 compare, so it is also 40 is less than, so no swapping. And in this way this will term. So this is the smallest this is the smallest list. So n number of element is required, but what is happen that this may be sorted if elements is a little sorted. Means this is the average case, I mean not a worst case. Worst case, what will happen? 50, 40, 30, 20 and 10 element like come like this. Okay, so exactly 5 iterations will require in that case. Okay, so that will happen in the worst case. Now the logic in program, how we will write the logic, how we will write a program. So as you know that we have each iteration we go from 1 to, means 0 to n minus 1. Okay, n minus 1, 0 to n minus 1, the index values. This is the index values. Yeah, now see, this is the at the index of 0, this is the n minus 1. Okay, and this is first iteration will require that much. Okay, and one more iteration will run simultaneously. The iteration number first is this, means loop. How many loops are required? 2 loops. First for this means n. Okay, n is our 5, so n minus, if we start from 0, so 0 to 4, so n minus 1, so 0 to n minus 1. Okay, so let's see the program how we will write. So in a Java, I am creating the program in Java. Okay, so first we create a class, suppose bubble sort. Now see, if I have a list of A where element is like the same, I will write like this: 50, 20, 30, 10 and 40. Okay, so how it will start? I will start from iteration 1 first, from 0 to I is less than what? A dot length. Okay, a dot length minus 1. If I will do or directly I can say I is less than in this length. Okay, I will increase. Okay, and then now the second loop will j equals to 0, j is less than, same thing, length and j plus plus. Okay, so now the exact logic, what will happen when we will swap? Our iteration is now start. Okay, so swapping will done. Swapping means if what is happen, a of j, okay, at the left hand side element a of j is greater than, okay, is greater than a of j plus 1. Suppose this is the case. Okay, if it is happen in that case, okay, here I will write a with element which name is temp. So for temporary store the elements. Okay, temp equals to 0, and what is happened that this is the condition where we need to swap. So how we will swap? Suppose there is two elements, okay, 50 and 40. Now if I wanted to swap these two elements, how we will swap? So what I am doing in a temp is another element where I will put this element, means this is the j and j plus 1. What is 0 and this is the 1 at the index of 1. What I will do, there is a 50 and 40. Now I have another element temp, okay. So what I will do, in this place at the 0 place I will empty this. First I will empty this, and how I empty, I will put it in temp a of j, okay. So now this place is empty, and in that case a of j equals to a of j plus 1. Means what I did, means this is empty. Now 40 is come to here, means 40 is stored here now, and in the temp there is a 50. I hope it is clear to you, not complex. In a temp variable, first I put this values, j values, okay, means the left hand side values I put in a temp, and then second step what I did, at the j plus 1, means the left hand side I put it at the right hand side, okay. So here what is happened, in temp 50 is come in a of j, means at the 0 index what values are 0, index of 1 means j plus 1 means 0, and here index of 1. So index of 1 values will go to the index of 0, means what 40 is go to here, and at the next iteration a of j plus 1 means this is now this is empty, okay. Here we can do anything, so we will not lost any values. So temp will come to the next index, so 50 is come to here. What is exactly happening, 40 and sorry, here is 50 and here is 40. What I am doing, first I am putting it in a temp, okay, and then temp is 50 in a j a of j, means here first I will save in a temp these values, okay. So whatever I wanted to put here I can. So what I am doing, 40 is swapped to here, means 40 is come here. Now 50 I can put here, so nothing will lost. If I will not use temp, what will happen in that case, if I 40 will I swap to here directly, then what will happen about 50, we will lose this values. So that's why I use temp, okay. There is another way that we can do the swapping also, but this is way which is here I am using. So temp, in a variable temp I will put a of j, okay, and what a of j, at the a of j I will put a of j plus 1, and a of j plus and a of j plus 1 I will put temp to here, okay. And in this way this will done. See, in the last what I can do, int I equals to 0, I is less than a dot length I plus plus. What I am doing here, just printing the elements, sorted elements, okay. So system dot out dot print ln, okay, and value of a of I. Here I will write system dot out dot print ln sorted array is, okay. This is just a message to print, okay. This is the case, and one more case we can do one thing, that as you know that if suppose there is no swap, okay, no swapping is done, then what will we do, we will break the both the loop, okay, in the complete iteration. So in each iteration here I will, what I will do, in the first loop there is a element swap, okay, swap equals to 0, okay. And suppose one, at least one swapping is done, we will do swap equals to 1, means Okay, swap equals to 1, it shows that there is swapping is done. If in any iteration there is no swapping is done, that means our elements is sorted. Okay, so rather than going to the ahead means all other iteration is unnecessary. In that case, what I will do after this first loop, okay, after this first loop, here what I will do, here see, code is here I'm writing. If swap this value, okay, if swap equals to 0, okay, then what will I will do, I will break. So this outer loop will be break, means complete iteration will be break. Why? Because elements is sorted. So in that way, in that way we can reduce the complexity if our element is little sorted or all are already sorted. Okay, so this is the one two line of code we can add so that we can reduce the iterations, number of iterations. Okay, so what is the complexity? So it is you know that we are going from n and this is n. So in the worst case all loop will work, means we all n will till we will go to suppose n equals to 5. So this loop will iterate at the 5 times and this will 5. So this is at the once it will iterate, so 5 times this will iterate. So at the 1 5, so 5 times 5 into 5 25. So so not 25, okay, 5 into 5. So what is exactly the in the worst case complexity? N square. Okay, in the best case there is this. So this is the complexity average and worst complexity, and best complexity is big of n. Okay, so let's see the program. कोड लिखते हैं फटाफट से, तो मैं क्लास क्रिएट कर लेता हूँ. ओके, सो ये मैंने एक क्वेरी क्रिएट किया एंड यहाँ पर हम बुलियन लिख लेते हैं जो कि स्वैप, एंड राइट नाउ इट इज़ फॉल्स. 0 1 वैल्यूज ले सकते हैं या ट्रू फॉल्स भी ले सकते हैं, एंड इंट टेम्प इक्वल टू 0. okay, and now start our loop from int I equals to 0 to I is less than a dot length, and again for loop int j equals to 0 to j less than again a dot length j plus plus. Right, if now swapping when if a of j is greater than a of j plus 1, if this is the condition, if this is, then what we will do, temp we will swap temp a of j plus j, a of j first we will keep in temp, then a of j equals to a of j plus 1, a of j plus 1 equal to temp. Okay, and here is first loop and here is second loop. Okay, here we will check if, okay, and before swapping what we will do, here we can, before of here anywhere in if loop, swap equal to true because swapping is done. Okay, so yes, here swap equal to false all the time, and if after this loop if swap, so if not swap then we'll break the loop. Okay, and at the end of this loop, outer loop also, now we'll get the final our sorted array. So out of print ln, then same system dot out dot print ln what a of I, and this is run. Okay, so this is our code, and here we can, one thing we can reduce because it is unnecessary, so we can do this. Okay, because we are checking already I plus 1 also, so 1 less. Okay, so this is our code, and now let me run this complete program. Okay, so you can see the sorted list is here. Okay, so by sweeping we actually reduce the number of iteration also. By sweeping means by these lines we are required means as much we required only that much iterations we will do. Okay, so we can see we can also here write the how many iterations are required. So by the count we can do this how many iterations are required. Okay, so this is the code you can see, and we can improve in this a little more. And this is your final code where we also write some this swap logic. Somewhere you will not find that this logic, because it is in our hand. If we want to improve the code we can write this. Okay, I hope this is clear to you. If any doubt please let me comment in comment section. And thank you for watching this video. Please like, share and comment, and thank you for watching. Please subscribe to our channel.